Once again, good morning, ladies and gentlemen. I've been charged with the responsibility to moderate this session. Let me introduce myself again, Valery Zaichko. I'm a head of department at State Space Corporation ROSCOSMOS, which deals in remote sensing and the remote sensing satellite application. Interaction with international organizations and different countries as far as remote sensing is concerned. We're going to start this session, which is called Modern Remote Sensing Satellites. Before we start with the first talk, I would like to say that the title of this conference, From Imagery to Map, shows exactly that imaging of the Earth by various means is very important, especially for mapping applications, for creating maps. And there is a reason why under the UN Committee for Space Usage for Peaceful Purposes, there is a notion of space geospatial data. It means that spatial data in general and space data in particular is in tight focus globally, including at the United Nations organization. Recently in St. Petersburg, a week ago, we, Russia, conducted a regular meeting of the Earth Observation Task Force, GO, and at that meeting a lot of attention was paid to the usage of space geospatial data for sustainable development of countries, developing countries in particular. As I pointed out yesterday, we are very pleased to be in India. We have warm and friendly relations, including in the field of photogrammetry, space photogrammetry, and space in general. Allow me to share with you what's happening in Russia in the field of space data, remote sensing data. The main document that defines the space program of Russia and primarily remote sensing development is our space program. In 2016, we adopted a new Russian space program from 2016 until 2025, which has two major sections dedicated to Earth remote sensing from space. First of all is development of the orbital constellation and development of ground infrastructure, reception and storage of remote sensing data. Whilst previously the Federal Space Agency dealt in remote sensing, today it's the State Corporation on Space Activities that does it, but the name has not changed, and the functions too. It's ROSCOSMOS. ROSCOSMOS. And the same functions have been carried over. This is a state corporation, the only authorized body in Russia which deals in outer space activities, conducts a federal space program, the program GLONASS, and a number of other space-related programs. But the key document defining remote sensing development is the federal space program. Besides developing the orbital constellation and the ground infrastructure, attention is also paid to developing technology for processing remote sensing data and developing products related to remote sensing. We also pay a lot of attention to interaction with other state bodies and international organizations engaged in space. Now, as far as the orbit constellation goes, at the moment we have 8 satellites, of which 4 are Resource P. We have 3 identical satellites and Canopus V. They can be used and are used successfully for creating topographic maps, for building other spatial information. 4 other satellites are hydrometeorological ones. As for their scope of application for mapping, I think the title speaks for itself. These satellites are used specifically for addressing meteorological needs and tasks. This slide structurally shows the composition of the constellation operating in Russia. So at the bottom there is also Belarusian satellite BKA. These are twin satellites, identical satellites, and we use them together in one orbital constellation. This is an example of international cooperation, of data sharing, which is what we're doing with the Indian side and what we're intending to do with BRICS countries. This slide shows orbital constellation specifications. All this data is available in space. If you're interested, I'll leave my presentation. So the main satellite we feature is Resource P, that you heard a lot about. Today it's important to note that we have developed the space system of Resource P, consisting of 3 satellites positioned in 2 orbital planes, which allow us to optimally plan space imaging. A few examples I'd like to show you from Resource P. The peculiar feature of these satellites is that apart from high-res data obtained in panchromatic and multispectral modes, panchrome 0.7, 0.8 meters, multispectrum 2 to 3 meters. Also, it features 2 types of equipment on board. This is a wide swath equipment with resolution of 12 to 13 meters, and the swath width is 120 kilometers. Besides, this satellite also features a hyperspectral camera with resolution of 25 meters, and we can use them jointly, providing great benefits for various tasks. This is the second satellite, Canopus V, with 2-meter GSD. but you can still create 25,000 and lesser scale maps. There's a couple of pictures taken from Canopus. As for Meteor M and Electra, I will not elaborate on them. I'll just quickly show you some images taken and their outward appearance. These are images captured by Electra. It displays a geostationary orbit, enabling to cover Earth every half an hour to form global weather forecast in infrared band and in bands. So it uses 8 bands, and it's very important for weather forecasting. Next year, we plan to launch 2 more satellites, one Canopus V with infrared gear on board. The only difference it will have is that apart from observing the Earth in 2-meter resolution, it will also feature an infrared camera to monitor fires. And if this experiment goes well, the next series of Canopus satellites, which we plan to launch 4, will also have this camera mounted. I already said that the 3-satellite resource system has been put together. Apart from the orbital constellation, it also has a distributed receiving and processing data system. The construction of this system allows on a daily basis to cover more than 500,000 square kilometers, and it is able to revisit the same point on Earth every day. This is the approximate makeup of 2017 constellation. Our plans call, well, this is the evolutionary path of the constellation since 2006 until 2016. But our plans, the space program plans, call for improvements and upgrades of orbital constellation that we have, including to address mapping tasks. So this is the composition of this constellation as we speak. Thus, the Russian space program, by the end of 2025 planning horizon, is planning to have up to 28 to 30 satellites, and this is how the envisioned constellation will look until 2025. On your right are space systems for natural resources and mapping applications. So resource PM will be new satellites with resolution of 0.3 to 0.4 meters or 30 to 40 centimeters GSD. This period is noted for the launch of 2 sets of radar satellites. The first ones are Condor satellites, they're not shown here, with a GSD of 1 meter. They are to be launched in 2018-2019. This slide doesn't show it because they will be replaced by Obzor R radar satellite with resolution, with 1 meter resolution, plus hydrometeorological satellites. We pay a lot of attention to this area as we strive to be independent of meteorological observations. And another point of interest is another meteorological satellite set to observe the Arctic area. And a couple of words I wanted to share about the ground infrastructure, which is the backbone of data receiving and processing. The year before last, I was here in Hyderabad, in the Indian Remote Sensing Center, and our development of ground infrastructure coincides with that in India. Our system is called the Common Territorially Distributed Information System of Data Receiving, Storage and Dissemination, or ITRIS, DZZ in Russian. In India it's IMGEOS, which translates similarly Indian infrastructure of remote sensing data receiving and processing. And we agreed with our Indian colleagues to consolidate efforts to share data but also technology. I hope that this will serve for the benefit of our countries and the entire photogrammetric community as well. This is the structure of our ground infrastructure with large reception centers at the core. The first line, stretching the southern border, is located in Moscow, Novosibirsk and Krasnoyarsk, and the far east area, Khabarovsk, and at Vostochny, in the town of Tsiolkovsky, there is a large reception center. And the second line follows the northern edge, which is not yet connected with data exchange lines. It features three large centers in Murmansk, which we opened together with Ministry of Emergencies, next year in Dudinki, and after that in Anadырь. This is Murmansk, Dudinka and Anadырь. Besides, similar to Indian colleagues in many ways, in 2018 and 19 we plan to deploy a center in the Antarctic. This ground infrastructure will allow us to substantially enhance capabilities of orbital constellation to receive, process, store and disseminate an enormous amount of remote sensing data received from the aforementioned constellation. Он все слушает. Все.
The second element is the portal of ROSCOSMOS to ensure access to remote sensing data and to download them and process. This is this geoportal, and that's what it looks like. In conclusion, I'd like to say that as of now, ROSCOSMOS is doing everything possible to make sure that our Russian data are used to the full extent to resolve and address many tasks, including mapping tasks, cartography tasks, and sustainable development of our country. Thank you. If you have questions, I'm ready to take them. Adrov, Rakurs. Mrs. Zaichko, on the global market, Russian data are not present at all, despite the fact that the orbital constellation is growing, and it's obvious that we can be competitive. As far as I know, now there is a task to commercialize the data. In our country, we're very much used to planning. So are there any bullet points that we want to reach? Because to supply our data to the commercial markets or global markets, do you have plans to carve out a niche in the global market or ensure a certain flow of revenues? Thank you for your question. I'd like to say that we are a governmental organization, and first of all, the government set a task under the previous federal program to ensure our state bodies with to supply remote sensing data to state and governmental bodies of Russia. And this task has been largely fulfilled to 80 to 90% of all their needs, not only governmental authorities, but all our regional executive authorities are fully supplied by remote sensing data for their daily needs, not only for mapping, but also in the interests of disaster monitoring, flood monitoring, urban development, and so on. By the end of 2015, our capacities have considerably grown, and now, indeed, we can eye a global market of remote sensing data, and we do have this possibility because of the constellation of satellites like Resource P. It's clear that the market is very competitive, but still, we have prepared a package of documents which in the next few weeks is going to be submitted in order to connect the current commercial companies in Russia who are at the moment are selling foreign satellites data like of Zones, Connex, Rockers, Prime Group, Rostelecom, and a number of other companies who we have preliminarily negotiated with and are prepared to distribute these data. Hopefully, these measures will help us to enter the market. Also, we have a number of agreements at governmental level with some countries who we share the data with. It's also a market. Maybe it's not commercial, but our data are known by some countries at least. More questions? Then, dear colleagues, if there are no more questions,